Factorization was something that we were introduced to last year. One thing that you should know by now is that you always look for a common factor. That should be your first step whenever you are asked to factorize something. And once you've done that, then it's helpful to check the number of terms, 2, 3, 4 or more terms, and that will guide your approach to factorizing. If you've got 2 terms, then have a look. Do you have 2 squared terms? Because then you can do the difference of 2 squares. Or this new one that we learn in grade 10, the sum or difference of 2 cubes. If you've got 3 terms, you look for a trinomial. And we also build on our knowledge of trinomials, because in grade 9, we looked at trinomials that started with x squared. And now in grade 10, we're going to start putting coefficients in front of that x squared. And that's going to change things up. So trinomials. And then finally, if you've got 4 or more terms, have a look if you can group them. Let's start by recapping what we learnt in grade 9 and looking at some examples of those. So the question will simply say factorize or factorize fully, and we have a look and see what we can do. Remember, step 1 is to always look for a common factor. So 5x squared minus 10x, what we can see there is a common factor, a 5x. And so what are we left with? In order to end up at 5x squared, I need to multiply by 5x by x. And in order to end up at minus 10x, I need to multiply 5x by minus 2. So there we go. This one, what you may notice, is that the common factor is a whole bracket. 2a plus b appears in both of those brackets. Now it's always good to check. What you'll notice is that these brackets are actually not written in the same order. The first one is 2a plus b, and the second one is b plus 2a. But when it comes to adding, we are allowed to change the order of terms. That's known as a commutative property. So in other words, this is in fact the same as 2a plus b. And so since the bracket is common, I can take out a whole bracket as a common factor, 2a plus b, and I'm left with 5y minus 3z. But have a look at example 3, and we'll see, are these brackets the same? So the question looks so similar. 5y, 2a minus b, minus 3z, b minus 2a. Now subtraction is not commutative, but there is a way that we can change the order inside the brackets. So let's leave the first brackets, because if we change both, then they'll still be different from each other. I'm allowed to change the order here to 2a minus b if what I do is I change the sign outside from a negative to a positive. So what happens is, because I multiply that term by a negative, it ends up switching the 2 terms in the bracket. And so once I've done that sign change, I can now look for a common factor, and I can say this bracket is in fact common to both terms. So we can take it out, 2a minus b, and we're left with 5y plus 3z in the second bracket. Let's look at some more examples. So we've got x squared minus 9. I don't see a common factor, but what I do notice is that x squared is x times x, and 9 is 3 times 3. So that's 2 squares. And so this is the difference of 2 squares. So I can then make my 2 brackets. The first bracket, what times itself gives me x squared? That's going to be x. What times itself gives me 9? That's going to be 3. And the one is positive and the other one is negative. That's how the difference of 2 squares works. Look at example number 2. So step 1 in factorizing is to always look for a common factor. So what can I see? I can see that 2 goes into this and into this. And here's an m. And this one has 5 m's, m to the power of 5. So I can definitely take out a 2m. And I'll be left with m to the power of 4 minus 16. Okay, now I ask myself, is this the difference of 2 squares? Well, m squared times m squared gives me m to the 4. And 16 is 4 times 4. So that is definitely a difference of 2 squares. So we've got the 2m that we factored out. And then this bracket is now going to become 2 factorized brackets. So m squared times m squared gives us m to the 4. 4 times 4 gives us 16, and one bracket is plus and one bracket is minus. Okay, we have definitely factorized, but have we factorized fully? Have a look at what is still sitting here at the end of this expression. That is in fact another difference of two squares. Okay, difference only applies to negatives, so we're going to have the 2m be m squared plus 4, that's the sum of two squares. But this final difference of two squares can again be broken up. So m times m gives us m squared, and 2 times 2 is equal to 4. And 1 is plus and 1 is minus. So to factorize fully, we need to always be on the lookout. Sometimes we factorize and it ends up again being a set of terms that can be factorized further. Let's take a look at trinomials. So here we've got x squared plus 2x minus 35. And so what we want to do is we want to look at the factors here that make up 35. So 1 times 35 and 5 times 7. And once you've got the factor pairs, you have a look and you say, which one of these pairs can give me this positive 2 that makes up the coefficient there of the middle term? Okay, and that's definitely going to be a 5 and a 7. So then what you want to do is you want to take your two brackets, and you're going to say what times itself gives us x squared. That's going to be x times x. And then we want to use a 5 and a 7 to create a positive 2. So if I have positive 7 minus 5, that'll definitely give me plus 2. And then we always do a final check. And the final check is to multiply this sign and this sign and to check, does it give us the sign of the last term? Okay, why? Because a minus times a plus is a minus, and 5 times 7 is 35. So we just want to check whether or not our brackets represent the expression that they came from. Okay, and the next one, 2y squared minus 12y plus 10. Okay, before we make this more difficult than it is, let's have a look for that common factor. There's definitely a 2 here. So y squared minus 6y plus 5. And now I can factorize by looking at the factors of 5, and it's just 1 and 5. It's a prime number. So that's 2. I'm going to have a y and a y, a 5 and a 1, and I need to make a minus 6 middle term. So that's going to have to be minus 5 minus 1, and then we do our final check. What is a minus times a minus? It does give us a plus. So that is factorized fully. Now that we're in grade 10, we are going to get trinomials like this. So 3x squared plus 7x plus 2. Have a look at this. This 3 is now a coefficient of the x squared term, and there's no constant factor here. So what we're going to have to do is factorize with this 3 in mind. Okay, and there are a number of different ways. But what I have found is that the teachers in the higher grades, so in other words, the teachers who teach matric, they strongly encourage you to do a method that doesn't involve 6 or 7 lines in your paper, because what happens is you run out of time. So let's have a look at one of the really quick ways of doing it. And of course you are welcome to do any method that works for you, but at the end of the day we need to be cognizant of our time so that you always finish your tests and exams. Okay, so what we do is we look at our first term, 3x squared, and we break it up into factors like we would have in the past. So our first term there can be written as 1x multiplied by 3x. Okay, the next thing we do is we look at the last term and we write down that term's factors. So that's going to be 2 and 1. And once we've done that, we can cross multiply. So 3x times 2 gives us 6x, and 1x times 1 gives us 1x. Okay, and now that we've done this, so step 1, factors of the first term. Step 2, factors of the last term. Then step 3, cross multiply. These are really just values that help us work out. Can I use a 6x and an x to make a 7? And the answer is yes. If both of these are positive, that will work. And so what you do there is you take that positive sign and you put it in between the terms that you used to get that value. So this essentially means that my brackets are going to look like this. 1x plus 2 and my second bracket, 3x plus 1. Okay, so 1x plus 2 and 3x plus 1. And now let's just check ourselves and FOIL this to make sure that this method works. So first term, let's write here a FOIL check, because if they've asked us to factorize, we can't multiply out, then we're doing the opposite of what they've asked us to do. But let's see, x times 3x is 3x squared, outer x times 1, inner 2 times 3x, and last 2 times 1 is 2. So we end up with 3x squared plus 7x plus 2, which was the question that they asked us to solve. Okay, so there we have it. We did complex factorization and we did it all in one line. Now let's have a look at the other new approach to factorizing that we learned this year, and that is the sum or difference of cubes. So we used to the difference of two squares, and that's a subtraction thing, and you've got to have a square and a square. In this instance, this actually works whether you have sum plus or difference minus. You can apply this whole process. Okay, and sum or difference of cubes is not too difficult. You just need to learn a couple of things. Okay, so the first thing we have to do is we have to recognize that this is x times x times x, and this is 4 times 4 times 4. That helps us to be aware of the fact that we are dealing with the difference of cubes. And now we are going to have a process that we apply. We're going to have one smaller bracket and one bigger bracket. Okay, what we do to get our first bracket is to take the cube root of this term. So x cubed, in other words, x times x times x, that's what I would do. I would just put one of them down. Then I keep the sign the same. So it's a negative. This bracket stays a negative. And then what I do is I have a look at the 64 there, and I say what times what times what gives me 64, and the answer is 4. Okay, so what have we done? We've taken the cube root of the first term, the cube root of the last term, and we've kept the sign the same. Now this first bracket that we've worked out is going to help us complete the second bracket. And this is how we do that. We square the first term, so x squared, and we square the last term. Minus 4 times minus 4 is positive 16. And then what we do is we multiply the two terms together. 4 times x is 4x, and then we change the sign. So it's going to be plus 4x. So to recap, we took the first term and we squared it. We took the last term and we squared that. And then to get the middle term, we multiplied x times minus 4 and we changed the sign. Let's look at one last example. 27y cubed plus 1000. Is there a common factor here? It doesn't seem like there is. Are these all cubes? Let's check that out. Okay, so 27 can be written as 3 to the power of 3, and 1000 is 10 to the power of 3. So yes, we've got 3 cubed, y cubed, and 10 cubed. This is the sum of cubes. Okay, what do we do now? We work out our first bracket, and we say we're going to take the cube root of this. So cube root of 3 cubed is just 3. Cube root of y cubed is just y. Keep the sign the same, plus cube root of 1000 is 10. And once we've got our first bracket, we can use it to work out the second bracket. So what do? We square the first. So 3y times 3y, that's going to give us 9y squared. We're going to square the last. 10 times 10, that gives us 100. And then finally, we're going to multiply the two terms inside the bracket. So 3y times 10, that's 30y. And we're going to change the sign, so minus 30y.